Okay, here is the solutions for the review mock of correlation and regression. Um, the marks obtained by 8 candidates in physics and chemistry tests are given below. So, looks like we have a range of about 4 to 12 in physics, and we have about 5 to 15 in chemistry. And we're going to first find the product moment correlation coefficient R. And remember, if your calculator has been recently reset, especially right before the exam, I'm going to show you how you do a reset, because a reset is not just something the test administrator is going to do. It's also something you might do if you screw up your calculator in the process of using it and you want to go back to the original settings. You go to reset here, and then you go to all RAM, okay, and then this will do, it'll return everything to its regular setting. So after this is done, one of the things you're going to want to do is turn back on the display for product moment correlation coefficient R, which you do by going into second catalog, and then you scroll down to where it says diagnostic mode on. Diagnostic mode, diagnostic on. Okay. All right. So now it will display the R coefficient whenever you do a lin reg. Okay. Then the next thing, or so now you want to put this data in so that you can run lin reg and actually see what R is. Remember that R, we're going to go into option, oh, I'm sorry, we're going to do cal edit because we're going to put the numbers in the calculator. And you see all my lists are full. I'm going to go into L1 and L2. I'm going to do a clear, and then it'll clear the whole list if I do the clear on top of the L1 and L2. Don't do delete because that deletes the list, and then you need to do some work to get it back. Just do clear. So I'm going to put, look, they're nice. They say that physics is the x-axis, chemistry is the y-axis. Remember, the x-axis is the horizontal one, vertical axis is the y. You just need to memorize that, okay? So 6 and 8, I'm going to put 6, and then here I'm going to put 8, okay? And then I'm going to go through, I'm going to put all the rest of the numbers here, and I'm not going to bore you with that, so I'm just going to pause this while I work on that. Okay, I've put in all the data for list 1 and list 2, and now I'm going to run linreg on it, which I do by stat calc linreg, and L1 and L2 are already here, so I don't need to change it. But if I didn't need to change it, I would do second L3, for example, and see that changes to L3. So I'm going to change it back now. Second L2. See there's L2 there. And then I'm going to calculate. Okay. One of the things I can also do while I'm doing this, I can store the equation that comes out, I can store it into y1. Okay, so the way I do that is I go alpha, function 4, and then I choose y1, enter. And so now it's going to put the equation that comes out into y1. Then I don't need to like copy it down on paper and then input it again. Pretty handy. Not easy to remember, but okay, so here's the equation. The equation is y equals 1.154. And this is already the answer to B, so I've already done B also. So I'm going to write that down here. Y equals 1.15x plus C, which is the B here, 0.976. Okay, and then look at the R. The R squared is 0.931. The R is 0.965. So I already have my R value, which is 0.965. And this didn't quite fit in there, did it? But I am going to make it fit. Isn't technology wonderful? Okay. Next step. It says the ninth candidate obtained a score of 7 in the physics test, but was absent for the chemistry test. Use your answer in B to estimate the score he would have obtained on the chemistry test. So you can do this a variety of ways, and the easiest way, in terms of not having to memorize anything with the calculator, is to just plug the 7 in for x in your formula or the equation that you got in B. And then just use your calculator to calculate that out. So we'll do that. We'll go to the regular prompt, and then we'll type 1.15 times 7 plus 0.976. And we get 9.026. So even though the answer is 9.026, you might want to say, oh, he'll get a 9, because you see that in the scores over here, they're all whole numbers. So if you're going to guess his score, maybe you're going to guess that it's a 9 because it's close to 9 there. The other way you could see that is you could go to y equals, and then we can see that, hey, look, and I'm going to erase this one here. Oh, there we go. I'm going to erase this equation here so that we only have 1. And you can see that by putting y1 in that field in stat, calc, lin, reg, it actually puts the equation in here and it puts all the digits available without you having to type anything in, which is pretty convenient. Then we can graph it. And how lucky it actually came out on the graph how we wanted. Okay, but remember, there's two ways to adjust the graph. One is by zoom, the other is window. First thing you always want to do if something's not coming out on the graph is do a zoom fit, which is zoom and then option 0. Okay, you always want to do a zoom fit. And then the other thing you can do is you can adjust the x-axis. Oh, I don't want it to show from 0 to 100. I want to show it from 0 to 1,000. You can fix that with window. In window, you can tell it that the x-min should be 0 and the x-max should be 1,000, for example. Okay, so let's make sure that our window size is the way we want it. Well, the x-min is -10, the x-max is 1,200. Well, that's pretty big considering all our test scores are below 15. So we could change the x-max to 20. And then we'll graph again. And then we're going to check to see and now we need to do zoom fit again because we adjusted the x-axis and the zoom is super zoomed out. Go down to zoom fit again. Okay, and then now we're going to see what the value of the y is when x is 7. Okay, so when x is 7. When he gets 7 on the physics test, what would that mean for the chemistry test? And there's two ways to do that. One is to use trace. So I'm going to do trace, and then see x equals 5 right now, but I want it to be 7, so I type in 7, and then I hit enter, and then it gives me, oh, when x equals 7, y equals 9.05 or 9.06. A little bit different than this number because you see I only had 3 significant figures here, so it turns out to be a little bit different. 9.06. Which still rounds to a 9. Okay. Finally, the last way you could do it is doing a second table. And when you do a second table, you could go right to x equals 9. 7, x equals 7, and look, there's that number again, 9.06. Okay. So those are 3 ways you could do part C. All right. But it helps to do, write this out in case you get it wrong. If you write this out, then at least you'll get partial credit. D, give a reason why it is valid to use this regression line to estimate the score on the chemistry test. Okay, what they're looking for here is they want you to be able to understand that, do you remember in the investigation? When we did the investigation, we had trouble using our regression line to estimate arm and leg lengths for people outside of our data. Like all of our data was like 11th graders, right? So when you tried to do a sixth grader, the estimate wasn't that good because the sixth grader is too far away from your data. Okay, so like if you have a linear regression line and it's based on the data that's in this cloud here, and you draw your line like that, it's like it can estimate well numbers in this region, but numbers outside of this region, the estimate is not very good. Okay, because you don't really know what happens outside there. Maybe it's not even linear. Maybe it maybe it curves out or something. Maybe it goes like this, and then your data doesn't really tell you that. So that's the problem with trying to estimate things that are outside of your data cloud. And in this case, 7, for example, is right in there, right? Because like remember, the smallest value in your data cloud was 4, the largest was 12. So 7 is in the middle there. So we can say, yeah, there's a reason why it's a good estimate because x equals 7 is within my data cluster. And the other thing you can say is that your product moment correlation coefficient is very close to 1. It's 0.965, right? So your R value is very close to 1. And remember, if it's very close to 1 or -1, then that means that your data really is linear at that point, and so it's valid to make a linear regression line. So those two things, if you do that, you're definitely going to get full points on that. Okay, and sometimes they'll give you X outside of your data cloud, and then you need to say, well, the reason why it's not a good estimate is because that X is outside of my data cluster. Okay. Number 2, following table gives the amount of fuel in a car's fuel tank and the number of kilometers traveled after filling the tank. On the scatter diagram below, plot the remaining points. Okay, so let's see what they got so far. 0, 55, 0, 55. And they have that. It's right there. 220, 43. 220, 43. They have that. 276, 30. There's that. 524. If you look at their data here, 524 they don't have. And you can mark it right there. And then 680, 10 they don't have. You can mark it right there. And then 856, they also don't have. You can mark it right there. Okay? And then you might be wondering, what is this point right there? We're going to see that in a second, okay? Because that's not one of the points that they give us. So we plotted the remaining points with red X's, and then it says the mean distance traveled is 421 kilometers, that's X bar, and the mean amount of fuel in the tank is 28 liters, Y bar. This point is plotted on the scatter diagram. Oh, so that's the point that we didn't know what it was. Okay, so we're going to say that's going to be like this point here. Okay, sketch the line of best fit. Now, what are they looking for here? The line of best fit needs to go through the mean point. So that point that's circled in blue is going to be one of the points of your linear regression line. Okay, and the rest, the angle of it needs to be such that, it's got about the same number of points above and below. So that's what it's going to be like. You're going to do it with a ruler on your test. That's how you're going to get full points. You're going to draw it through the mean point, and you're going to draw it with a ruler, and it's going to follow roughly the pattern of the points you got. So we've sketched the line of best fit. Then it says a car travels 350 kilometers. And so then we're here. And then we go up until we hit the line. And then we're going to go left. And we're going to get to about 32, I think. Okay? So use your line of best fit to estimate the amount of fuel left in the tank. I would say about 32 liters. okay, because of the line I just drew here. All right. Next problem. The number of bottles of water sold at a railway station on any given day is given in the following table. Temperature, number of bottles sold. So it's like they're saying that, hey, depending on what the temperature is, if it's hot or cold, then that determines about how many bottles of water you're going to sell. Okay? First it says write down the mean temperature and the standard deviation of the temperatures. Okay, so to do that, you are going to put all your data in the calculator, and then you're going to use 2-bar stats, which is different from what we've used before. We've always used 1-bar stats to find the mean. 2-bar stats is kind of the same thing, except for it'll consider the list 1 data and the list 2 data as real data and not frequencies, so it will calculate the mean for each one. Okay, so since we've already used, we'll go to stat edit. And since we've already used list 1 and L2 earlier on this mock exam, we're going to go up to L3 and L4. We're going to use those for this data. Okay, so first thing I'm going to do, I'm going to clean out list 3 and list 4 with clear, not with delete. Okay, so I go to list 4, I put my cursor on top, I press clear, I press down, and it's gone. Don't press delete. If you press delete, you're going to have to reset your calculator to get the list back, or some other methods which I can show you. Okay, so let's see. One thing I kind of want to know is which one of these is X and which one is Y. And let's see if I look to the bottom of the test, can I? Oh, there's a clue right there. Look, they give us the equation for a line, and the N is in the Y position, and the T is in the X position. So T is X and N is Y. So that'll help me when I input my data here. I'm going to put 21 in the first list, 20.7, and so on. And I won't bore you with the details here. I'll do it offline and I'll come back when I'm done. Okay, I'm back, and I have now input all my data into the calculator. I'm just going to go back through it to make sure that all the numbers look like they're there. All right. Okay, write down the mean temperature, which is the mean X value, and the standard deviation of the temperatures. The way you do that is you do stat, calc, 2-bar stats, because I want to analyze both X and Y. And so the first list is L3, so I go into here and I do second L3. And then the second list is second L4. There you go. And then I go down and I do calculate. And it gives me that X bar is 249. Oops. That's not X bar. X bar is 19.2. I noticed that 249 was quite a bit above the other temperatures. If the temperature is 249, you wouldn't be buying bottles of water. You would be jumping into the ocean. Then it asks me for the standard deviation of the temperature. So that would be sigma x, this one right here, 1.45. That says write down the correlation coefficient R for the variables n and t. So now we need to run the StatCalc lin-reg test. And we've already set diagnostic on, so we don't need to do that. L3 and L4. Yeah, it's set to L3 and L4. That's where we put it, right? L3 and L4. Okay. And then we're going to put calculate. And it'll give me R equals 9.42. No, 0.942, sorry. 0.942. Okay? And that says comment on your value for R. Well, 0.942 is pretty close to 1. So it is linear, strong, positive correlation. Okay? And how do we classify the correlation? Well, if it's positive, then you say it's positive. If it's negative, you say it's negative. And how do you know if it's strong? or weak, etc. Well, there's a table that we learned in our problem sets. 0.75 to 1 is going to be strong. 0.5 to 0.75 is going to be moderate. 0.25 to 0.5 is going to be weak. And 0 to 0.25 is very weak. So in this case, since it's between 0.75 and 1, we put strong. Okay, and of course it's linear, otherwise we wouldn't be doing that. Okay, sometimes you don't need to write linear. The equation of the line of regression is n equals dt minus 100. That's pretty close to what we got. We have minus 100.3. They said it's minus 100. So to three significant figures, it's correct. Write down the value of d. Their d is actually rm, right? So or ra. And in our case, it says a is 11.5. So we're going to say that, oh, in that case, it's 11.5. We can write out here our mx plus b here, or ax plus b here. 11.5 x minus 100. In this case, x and y, remember, is actually temperature and bottles of water. No, not bottles of, it's bottles of water is, what's the variable they use? N. Okay. So we just compare this with this, right? 11.5. Estimate how many bottles of water will be sold when the temperature is 19.6. Okay, so there's, just as in the other problem, there's a couple ways to do this. One is you could write, oh, n equals 11.5 times 19.6 minus 100, and then you could just multiply it out in your calculator. Okay, I'll do this on the offline calculator because it's faster. 11.5 times 19.6 equals 225.4 minus 100 is equal to 125.4. So n equals 125.4, but if we're just going to estimate the number of bottles of water, it would make sense to round it, so I'm just going to say 125 bottles of water. And the other way you could do that is you could put this equation into y1. So I'm going to go down. So if I go to stat, calc, lim, reg, and then let's say I want to put it into L or y2. I'll go to alpha, F4, y2, enter, and then go down to calculate. And then it's going to put that in y2. Let's check to make sure it's in y2. Yeah, there it is. And then we graph it. And maybe it's off the screen. Yeah, I think it is, because look at that, negative 100, so it's way, oh, there it is. Let's try to do a zoom fit, which is zoom option 0. There we go. Okay, and it probably does not have the value that we want. We want an x value of 19.6. Let's see if that's on the screen. So we'll do trace 19.6. There we go. It's 125.4. Hey, that's the same thing we got here, rounded to 125. The other way you could do it is you could take this equation here, and you can type it manually into y equals. If you don't happen to remember the button sequence to put it into y2 automatically, you just type it out here. Okay, so those are the three ways to do it. On the day when the temperature was 36 degrees, Peter calculates that 314 bottles would be sold, using this equation, of course. Give one reason why his answer might be unreliable. Well, remember in the previous problem, we talked about where the data cluster is. And in this case, the data cluster ranges from about, let's see, the low value looks like it's around 17. The high value looks like it's around 21. Okay, so like between 17 and 21, we have a lot of data. But what about 36 degrees? 36 degrees is way out of our data cluster. And so it's hard to be sure whether or not it's going to be linear outside of that point. So we have a data cluster kind of like that. and we drew a line through it, and then we're saying, hey, what about 36, which is up here? Can we make a good estimate on that? And the answer is, well, maybe not. Okay, so one reason why the answer might be unreliable is because x equals 36, or not x equals 36, but t equals 36 degrees is quite far outside of our data cluster. Okay, and that's it.